So we start off with a circle, and this circle is called the unit circle. So I'll highlight that. It's a circle with a center at 0, 0 and a radius of 1. So if you took that circle and you picked any point on that circle, and right now we're starting with a random point in the first quadrant right here. If you took that point, you could draw straight down and straight across and make a right angle triangle. Does it make sense that the one leg of that right angle triangle is your x coordinate and the other leg of that right angle triangle is your y coordinate? Now, any point you make on the circle can be described by the angle in standard position where it's at. So right now, we have an angle theta in standard position that ends so that we have the point P, x comma y. Now you know from grade 10 trig and grade 11 trig, you know SOHCAHTOA. So if we looked at sine of theta would be the opposite over the hypotenuse, which would be y over 1, which simplifies to just be y. And cos of theta would be the adjacent over the hypotenuse, which is just x over 1, which is just x. And if we are doing two of them already, we may as well write tan of theta as well. Tan of theta would be opposite over adjacent, which would just be y over x. And here comes the first big idea. Instead of labeling points on this circle as x comma y, or at least in the first quadrant, and then we'll see how it works in other quadrants as well, instead of writing x, x is equal to cos of theta. So this coordinate is cos of theta, and y is equal to sine of theta, so every single point on the unit circle can be represented as cos of theta comma sine of theta. So now all we need to know is the angle, and we'll know the point on that circle. At the bottom of your next page, there's some space at the bottom of the next page. So that's where we're going to start listing our three big ideas. Big idea number one is that any point So some key things that you're going to try and remember from this is that the x coordinate on the unit circle is cos of theta. The y coordinate on the unit circle is sine of theta. Big idea number one. Now, why does that happen to also, why does that also work for the other quadrants? Well, if I randomly chose a point in quadrant 2, so if I picked this point on the unit circle in quadrant 2, and I drew a triangle with that point, can you see that the hypotenuse would still be 1? Can you see that you would still have an x coordinate, well, it would be negative x coordinate here, and a y coordinate there? But as far as sine and cos go, you could do SOHCAHTOA again. And this angle would not be your angle in standard position. The angle inside your triangle would be your reference angle. And one of the things you learned about reference angles is that sine and cos and tan of reference angles are the same as sine and cos of tan of the other angle. So the coordinates will still be sine and cos, but it also explains some things, because can you see that in this quadrant, your x coordinate is going to be negative, and your y coordinate is still going to be positive. And it starts to explain why the cast rule. Everybody know, when I say the cast rule, everybody knows what I'm talking about. The cast rule says which trig function is positive in which quadrant. So the A means all of them are positive. The S in quadrant 2 says only sine is positive. And if you think about the unit circle, it makes sense that any point in quadrant 2 the x-coordinate will be negative, the y-coordinate will be positive. And so cos will be negative and sine will be positive. And since this works for any point in quadrant 3 or quadrant 4, you can always make a triangle back to the nearest x-axis, which creates a reference angle. You can say that any point on the unit circle can be represented as cos theta comma sine theta. Second big idea. We've got in the box here the equation of a circle. In fact, the equation of a unit circle. The equation of a circle is based on the Pythagorean theorem. A squared plus b squared equals c squared. Can you see that no matter where you draw a triangle, the x-coordinate squared plus the y-coordinate squared will equal 1 squared? And so we don't formally teach equations of circles. It used to be a unit in grade 12. They've taken that out, in which you could find a circle anywhere and write its equation. But the basic unit circle's equation is just this: x squared plus y squared equals 1. And if the x-coordinate is cos and the y-coordinate is sine, this leads us to big idea number 2. Instead of x, if I write cos, and instead of y, I write sine, I get cos of something all squared plus sine of something all squared is equal to 1. Now, on your formula sheet, mathematicians don't like writing brackets because it takes too much space. So when they decided, how am I going to write this, they decided to write the squared inside. And for whatever reason, sine is always written, usually written first. So instead of writing sine theta all squared, we put the squared in between sine and theta. Plus, same thing with cos, put the squared in between the cos and the theta, equals 1. And this is big idea number 2. You know how you memorized some values last year, right? For example, do you know what sine of 30 is? 1 over 2. Do you remember what cos of 30 is? Square root of 3 over 2. Okay, I'm going to get you to do some mental math. Get ready. Okay? I want you to think of sine of 30. Get that number in your head. I want you to square it. Keep that number off to the side. I want you to take cos of 30. I want you to square it. Keep that number off to the side. Now take those two numbers, add them up. What do you get? 1. Good. Good mental math. Now I'm going to push you. Okay? We're going to do some harder mental math. I'm going to pick an angle that you maybe didn't memorize, but I'm going to try to make you think about it. How about 37 degrees? Okay? I want you to do sine of 37 degrees and keep about 30 decimal places in your head. Okay? Square it. Keep that number off to the side. Now I want you to do cos of 37 degrees. This time remember about 50 digits. Okay? Got it? Now square that.
I got it.
Put that off to the side. Now take both of those numbers, add them up. What do you get? 1. Wow, you guys are amazing. That was like a lot of digits you had to remember to get that. And that's what this second big idea is saying. It doesn't matter what the angle is, as long as the angle is the same. It doesn't work if the theta here has to be the same as the theta over there. That sine squared of 37 degrees plus cos squared of 37 degrees is going to equal 1. It's always going to equal 1. And that will always happen. That's big idea number 2. And big idea number 3 is looking at tan. If tan is y over x, and the y-coordinate on the unit circle is sine, and the x-coordinate on the unit circle is cos, then we can say that tan of theta is equal to sine over cos, or sine theta over cos theta. And that is big idea number 3. And you can try it on your calculator. Pick a random angle, like 37 degrees. Type in tan of 37 degrees, push enter. It's going to give you some decimal answer. Then take sine of 37 degrees and divide it by cos of 37 degrees and push enter, and you will get the exact same number. Now, these big ideas are new for you today. However, I'm going to say that by the end of the year, you're going to almost think of them as common sense. We're going to use them so much that someone says tan theta, you'll be, yeah, tan theta is equal to sine over cos. I know that. Or sine squared plus cos squared equals n. Yep. It'll just be like, I knew that my whole life. That's what sort of common sense makes you feel. Sort of like a squared plus b squared equals c squared. Does that feel like that's common sense? Right? If you talk to any of your peers, you assume they know what that means. Right? At some time, if you go talk to my kids and say that, they'd be like, what are you talking about? Because they're only, 7 and 10, or almost, yeah, 7, 10, and 13. They wouldn't know what you're talking about. But now you feel like that's common sense. Like everybody should know what that means. Check. Okay. Do we do a test? Mr. Walks, do you know what a squared plus b squared equals c squared is? Have you heard of that? Nice. Is learning 3 new definitions of the reciprocal trig functions. So before you knew just sine, cos, and tan, and you probably remembered SOHCAHTOA, now you get to add cosecant, secant, and cotangent. Okay? So secant, and what we're going to write right beside here is that secant theta is the same as 1 over cos of theta. Cosecant of theta is the same as 1 over sine of theta. And cotangent theta, any guesses? It's the same as 1 over tangent of theta. So cotangent is really easy to remember that it goes with tangent, but you will mix up secant and cosecant. Maybe if you remember that they're mixed up, like the S goes with the C and the C goes with the S. I don't know if that helps. Okay. And since tangent is sine over cos, and reciprocals are flipping things, we can also write cotangent as cos over sine. So if you could remember SOHCAHTOA, right? What happens now, cosecant, if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. And if cos is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And if tan is opposite over adjacent, then cotangent is adjacent over opposite. And maybe this is easier to remember than SOHCAHTOA. Choshakao. 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 Yeah, that works out really nice. Don't memorize that. Because all you're going to do is if they tell you sine is 2 over 3, you're going to be able to say cosecant is 3 over 2. You're just going to flip the answer. But you can choshakao if you like.